In today's lesson, we're going to be looking at gravitational potential energy, what it is, how to calculate it, and how to answer exam questions. Gravitational potential energy is the energy stored in an object due to its position, or more simply, its height in a gravitational field. In this diagram, the bottom represents the ground. At this point, we say the gravitational potential energy is 0 joules. As the object is raised, it gains gravitational potential energy. So here, at the top of the cliff, the ball has maximum gravitational potential energy because of its height. The key idea is gravitational energy increases as the height of an object increases. So gravitational potential energy depends on the height of an object above the ground, with 0 at ground level, and then the higher that object is, the higher the gravitational potential energy. Think of it as stored energy, ready to be transferred when the object falls. Let's break down the gravitational potential energy, or GPE. The equation is GPE equal to mass in kilograms times the gravitational field strength in newtons per kilogram times the height in meters. So there are 3 things that affect GPE. First, the mass. If we increase the mass, the GPE increases. So a 2 kg object has more GPE than a 1 kg object for the same height. Second, the height. The higher an object is, the more GPE it has. So raising something from 5 meters to 10 meters increases its gravitational potential energy. Third, the gravitational field strength. On Earth, the gravitational field strength is 9.8 newtons per kilogram. But on the moon, it's much lower. It's 1.6 newtons per kilogram. So the same object will have less GPE on the moon compared to Earth. Overall, GPE increases if we increase the mass, the height, and the gravitational field strength. Now we are going to look at how to use the GPE equation and turn it into a triangle to help us rearrange it. The equation is EP equal to mgh. This is how it's provided in the exams for you. First, we draw a triangle, and then the GPE goes to the top of the triangle, the M, the G, and the H along the bottom like so. This works because GPE is found by multiplying these 3 values together. Now, the triangle helps us rearrange the equation easily. If I want to find the mass, I cover the mass, or M, then I am left with GPE divided by G multiplied by H. If I want to find G, or the gravitational field strength, I cover G, then I'm left with GPE divided by mass multiplied by the height. If I want to find the height, I cover the height. Then I'm left with GPE divided by the mass multiplied by G. This is really useful in exam questions where you're asked to find different variables. Let's try our first example. A 50 kg crate is lifted 4 meters. Calculate the GPE. So we have 50 kg, 4 meters, and we're asked to find the GPE. M is equal to 50 kg, which is the mass. H is equal to 4 meters, which is the height. And the gravitational field strength is 9.8 newtons per kilogram. We're asked to find the gravitational potential energy. Now recall our equation that gravitational potential energy is equal to mass multiplied by gravitational field strength multiplied by the height. Substituting our values, we have 50 multiplied by 9.8 multiplied by 4. And that gives us 1,960 joules. This time we're finding the height. A 0.5 kg football is kicked into the air and gains 49 joules of GPE. So we're going to be required to rearrange the equation. First, let's write out the values given in the question. So it says a ball of mass 0.5 kg. So M is equal to 0.5. It says the GPE is 49 joules, which is the gravitational potential energy. Height is unknown. That's what we are asked to find. The gravitational field strength is 9.8 newtons per kilogram. Now, looking at our triangle, we can find the height by covering the height, and then we're left with GPE divided by M multiplied by G. So we can write that here, GPE divided by M multiplied by G. Okay, that gives us 49 joules divided by 0.5 multiplied by 9.8. Okay, if we simplify this, 0.5 multiplied by 9.8, we get 49 divided by 4.9. And if we punch that in our calculator, we should get 10 meters. You now have some time to try these questions independently. You can pause the video and try to work these questions out. And then when you're done, you can check the answers. Here are the answers to the questions. I am going to go through the challenge question step by step, as that brings everything together. Looking at the challenge question, first, we need to write out everything given in the question. So we have a mass of 200 kilograms. We have 16,000 joules of energy supplied. That's called energy input or energy supplied, 16,000 thousand joules. We know that 20% of that energy is wasted energy. And that will be 20% of 16,000. And we know that the gravitational field strength is 9.8 Newton per kilogram. We're asked to find the height. That is something you need to know before you're able to solve a question like this. And that is the total input energy is equal to useful energy plus wasted energy. Now, the energy transferred usefully is our gravitational potential energy, which is this one. So we need to use this to find the useful energy. We do not use this to solve the problem, as that is the total energy supplied or the total input energy. We need to use this to find the useful energy. Now, we're told that 20% of the energy is wasted. So to find the value of the wasted energy, we do 20%, which is 20 divided by 100, multiplied by 16,000. And that would give us 3,200 joules. So now we know that our wasted energy is equal to 3,200 joules. We know that our total energy is equal to 16,000 joules. And now we can find the useful energy by subtracting 3,200 from 16,000. So 16,000, take away 3,200. I'm basically rearranging this equation to solve for useful energy. So that would give us 12,800 joules. Now we can use this equation, EP divided by M multiplied by G, okay, to solve for the height. The EP is 12,800. The mass is 200, given in the question. And we have 9.8 as our gravitational field strength. We could write that this way. 1,960, which would give us 6.5, approximately 6.5 meters. And that's how you solve a question like this. For this exam style question, we need to combine two equations. Power equal to energy transfer divided by time, and the equation for gravitational potential energy. So first, we need to find EP. And then we plug that equation in here to find our power. So EP, which is our gravitational potential energy, is going to be equal to 65 multiplied by 9.8 multiplied by 1.8. Do not forget to convert this to meters. To convert from centimeters to meters, you divide by 100, and that gives us 1.8 meters. So I got this 1.8 here. This gives us 1,146.6 joules. Now we can substitute this in this equation with our time being 1.5, and then we can find the power. It goes to 1,146.6 divided by 1.5, and that should give us 764.4 watts. Our answer is going to be 764.4. Now, the actual power output is greater than your answer in A. Suggest 2 reasons why. One possible reason is because of energy transferred to the surrounding. The work done against air resistance.